Hello and welcome to Graphs. In this section, we will explore the graph data structure in Java. We will start with an overview of the data structure and then take a hands-on approach by programming with the data structure. Specifically, we will create, traverse, and search graph data. Using the graph data structure to store relationships. In this video, we will learn the basics about the graph data structure and how to implement them in Java. A graph is a special node-based data structure that is used to manage node relationships. Each node is referred to as a vertex, and the connecting lines are called edges. When an edge connects two vertices, those vertices are adjacent to one another. These relationships can be one way or two ways. Graphs are abstract mathematical objects, and there's an entire field of graph theory that's beyond the scope of our time today. Here are a few things that you might use a graph data structure for: programming circuits, maps or route planning, computer networks, social networks, even production schedules. So regardless of the application, graphs are a collection of vertices and a collection of edges. There are two representations for graph: adjacency matrix and adjacency lists. The adjacency matrix is a 2D array, while the adjacency list is an array of lists. We use the matrix typically when the graph is full because it's easy to implement, it's fast. On the downside, it does take more memory. We'll use a list representation when the graph data is sparse, therefore it takes less memory. The downside is that the searches are not efficient. Let's look at this in code. I have the graph demo class. Open that. Scroll up to the top and we'll walk through this and then we'll look at the output. So we're implementing this using a linked list. So here's our main class, and we have a static class called network graph. So we have a class variable here called vertex that will determine the size of our matrix. We're going to call our graph my network. And here's the constructor. Takes in integer, which will tell us how big of a graph to make. And here we can make a new list based on the number of vertices that the graph will be as far as size goes. Main method here of the class, we're going to recreate this my graph, and then we're going to use the add vertex edge to establish relationships. We'll look at this method here in just a moment, but we're passing our graph, and then we're passing the starting and ending position of the edges, right? So this means that we're connecting node 0 or vertex 0 to vertex 3. And you can see the list here. So there are 9 vertices and they're numbered 0 through 8. And then here are all the relationships that were put in there. We'll look at this as an output when we call this method right here. And we'll look at that in a bit. So first here's the add vertex edge. We're identifying the graph, and then the starting position and the ending position of the edge. And this is how we'll put the start to end position in, and we'll do the reverse from end to start. Because when the edge goes between two vertices, there can be two ways. This is the way we'll output it. Simply print some header information, and then we'll traverse through, and we'll simply print out the head vertice, the number 0 through 8. And then as we traverse this graph, we're going to look at the head and we'll print this little indicator to show the difference. Okay, so that's all there is to it. It's pretty simple. We did say that they were easy to implement. So I'm going to scroll up to this part right here. So you can see, so that was our original input. Now let's go ahead and run this. So we have a column of the head vertex and then all the connections. So let's take an easy one here. We'll look at 3. Here we show that it's connected to 0 and 1. Here we can see that 3 is connected to 0 and 3 is connected to 1, and we do not see a 3 anywhere else in there. So this is a simple way to look at the output.